Hello teachers and students and class. I think you may sit down. Right. Today in our lesson, we are going to be having a little experiment. So be aware that the instructions will appear on the screen and you will follow the instructions. So cooperation with your group members is important. Right, let's look at our last lesson on particles. What did we say about gas particles? Yes? A hand at the back will have from group 1.
In gas, the particles are not held in fixed positions because the attraction is very weak, and so they can move or vibrate at high speed, colliding with each other and bumping off any surfaces.
Not held
In fixed positions.
fixed position. Sorry, properties of gases. What's the other property that you mentioned also?
Move at high speed.
Hey. Yes. Any others? Any other properties of gases? Give us the answer. Thank you.
Particles in the gas change directions.
Okay, they move at high speed, and when they collide, they change direction. Or when they bump into each other, they change direction. Any others? Can you pack gas? Can you squeeze gas? Sure. Hold the biro up. Hold the biro and try to squeeze the biro small. Can you squeeze the solid pen? It cannot be compressed. Now, can gas be compressed? Yes. Can gas be compressed? Yes. Gas can be compressed. Okay, good. Oh. All right, those are some of the properties that we looked at in particles of gas. If you're taking note, do take that note. Properties of gases down. Okay, we shall move on. Right, teachers and students. Our strand, we are still on the same strand, which is Science in the Home, our sub-strand, learning about substances. We are on the outcome 8.3.1, conduct investigations and use collected data to identify patterns in the physical interactions of substances. Our topic today is gases. How can we tell gases? Now we looked at the properties of gases, but how do we know that this gas, the gases we are looking at, will be either oxygen, hydrogen, or carbon dioxide? There are many gases, but these are the three common gases that we will be looking at. But since there are two other gases which will need a lot of time to do experiment, we'll be doing only one today. And that will be carbon dioxide, which we will be producing and we'll be testing if it is carbon dioxide. So before we start, I would like to have you clear your tables of what you have on them, and we shall go through our experiment. So others, you clean your tables, and the group leader, you may come up to the front to collect your materials. All right, may I have your attention? Let's go through our materials that we have on the table with us. Do not touch anything yet. The materials that we have on the table, I would like you to take care of them because some of them are glass materials which we'll be using. And be careful with them. Do not try to pull them or fiddle around with it because you might accidentally drop that. So you must be careful at all times when you're handling glass materials. Let's have a look at our first one. We should have in our tray a container, an empty container, or if you have beaker, a large beaker, that is okay. You have a small container which is marked X. In that container marked X is the liquid vinegar. So that is the container containing vinegar. The next is a small 75 or 100 ml beaker, small beaker which contains lime water. You should also have a piece of cardboard with you in the tray, a candle hooked onto a piece of candle hooked to a wire, and an eyedropper with you. So all those materials should be with you. Check that you have that. Right. In your activity, you will be following instructions. So you will be doing that together. Now, what I would like you to do is maybe you can divide each of you to carry out one instruction. So the first person will do one instruction, the next person will do another instruction. Your questions will appear with one of your instructions, and you will need to write down that question. So appoint someone to be your recorder who can record the questions down when your instruction appears. And your instructions will appear for only about 30 seconds. If it is a question, then I'll give you 1 minute to copy the question down, discuss with your friend, and move on to the next instruction. So get yourself ready, your reporters ready with a biro and a paper. We shall begin. Is there any questions about the experiment, or you're not sure of anything that I've explained? All right. Good. That means we are all aware and ready. Now let's move. Yes, no questions. Okay. If you find anything difficult during the experiment, please raise your hands up and you will be assisted. So, thank you. We shall begin. Your instruction number 1. You will need to have some baking powder, which we will use. A baking powder used to bake scones, flour, bread. So this will be the baking powder that we will be using. Right. Could I have one member of the group to come up and get your baking powder, which you will have on a piece of paper? Right, our instruction number 1. We used a big tablespoon, so it will be 1 spoon for your baking powder. So your instruction number 1, that is your instruction number 1. You shall follow that. You may pour the baking powder in because already I put the baking powder on the paper. Have we done instruction number 1? If you have done instruction number 1, you sit up straight so I know, and we will go to the next instruction. Your instruction number 2. You will be using the eyedropper, so you will pour about 10 drops of vinegar. 10 drops of vinegar into the container. Quickly. You must do that quickly. Another one. Be recording down your question. Your instruction number 4. Your instruction number 4, I will give you about a minute to do that. Now tell me, let's see what happened when you put in the burning candle into your container. What did you find out? Iowa?
When you place the candle in the glass of vinegar and baking powder, the candle off.
The candle went off. Why is that? Why did the candle go off or go out? Why did the flame go out as soon as we put the burning candle into the container? Okay, Iowa, want to add on to his answer? Yes, thank you.
Because there's no oxygen in the bottle.
Do you agree? Okay, some know why. Ella?
Because the container is full of gas.
Thank you. Because the container is full of gas, and the other answer was there is no oxygen. So if Ella says there is full of gas in the container, now what kind of gas is that? Yes, we have one answer. Answer at the back, our friend at the back. Diane, thank you.
Carbon dioxide was inside the bottle.
Carbon dioxide was in the container. How do you know it is carbon dioxide? How do you know it is carbon dioxide? Diane? Ella was right by saying that there is no oxygen. That is why the flame went out. So, fire or the flame needs oxygen to burn. So how do we know that there is carbon dioxide in there? How do we know? Yes. Group at the back again.
Because vinegar and baking powder makes carbon dioxide.
Right. Okay, because vinegar and baking powder produce the gas carbon dioxide. And so you found out that flame goes out when you insert the candle into the container, which contains carbon dioxide. So that is one property of carbon dioxide gas. Right, we'll do a simple experiment. Each of you will have, a group has a plastic bag, popcorn plastic bag. It's a clear transparent bag. I would like you to blow into that bag. Blow into the bag, plastic bag. Blow into the bag and seal. Okay, instruction number 2. Instruction number 2. You will use one full drop of lime water into the plastic bag. Now you may shake. and put it against a dark background so you can see what the lime water has, whether has changed or not changed. Has it changed? Compare the liquid with your in the plastic bag and the lime water in the beaker. Do they have the same color? Can someone tell me the difference? We have the group at the back to tell us the difference. The difference. What happened to the lime water? Ella? Can you tell us about your lime water in a plastic bag?
The lime water has changed color.
To what color?
Silver.
Silver. Okay, if you look closely, your lime water in the bag, which is used to test carbon dioxide, we breathe out and to test carbon dioxide, will turn powder or milky. So yes, cloudy, thank you. Milky or cloudy. If you see that change, then you know that carbon dioxide is present in the bag. And that is a test to identify carbon dioxide. So that is called the lime water test for carbon dioxide. Right, thank you. We shall go into our summary. If you do take note of the summary, somebody read and the other copy, so it will be faster for you to do that. We have this first summary. Carbon dioxide, the chemical symbol or the scientific symbol is capital C, capital O, and a little number 2 at the base of letter O on your right hand side. Next summary points. our key phrase for today. Anyone would like to give us our key phrase? Our key phrase for today?
Guesses.
Right, guesses. How can I tell guesses? Our next lesson will be on receiving teachers and students is how much is enough. These are the materials that you should prepare for your next lesson. We have sugar, salt. You can either bring sago or flour. Also bring cordial, pure cordial, a teaspoon, and some clear glass jar or clear containers. All right, thank you, students. That will be all for today. We shall see you in your next lesson. Thank you, receiving teachers and students and class.